It occurred to me that if I'm going to ask you to be able to delineate watersheds from maps, I should talk to you a little bit about how to interpret a topographic map. I realize this is something maybe some of you don't know how to do, so let's just go ahead and do it. Um, so, a topo map or topographic map, it uses a concept called contour lines to help us visualize changes in elevation. So, the idea is on a topographic map or a topo map, these lines, these contour lines, represent points of equal elevation. So in here, all of these equal 6,000 feet. So if I walked along this line here, I would not go uphill or downhill. I would be at a constant elevation. So, and if I go this way, I notice I'm going up towards this height here. If I go this way, I'm going downhill to this height down here. So what I see then is that as I go uphill, these rings are getting smaller and smaller and smaller until I'm at the very hilltop here, which I'm told by this number here is at 7,236 feet. So hilltops show up as these sort of bullseye patterns of concentric circles. Now, another thing about them is that we can tell the relative steepness of land by looking at the distance between contour lines. So, where we see contour lines are very close together, that means I'm changing elevation very rapidly. So, it's very steep. Like this right here is almost a cliff. And the farther apart they get, the less steep it is. So, if I look here, it's very far apart here. So, this is a very gentle terrain. And here I have a very steep, almost cliff like terrain here. So that's an important thing to be able to visualize. One is hilltops, which show up as these little bullseyes. The other one is steepness of land can be determined by how close together these topographic lines are, these contour lines. Now, this is really important. Okay, so when we see a river valley or a stream valley, whatever, when I see where I see running water, what happens is as it cuts in, it ends up making contour lines that make these V shapes. So when we see V-shaped contour lines, we should think, oh, that's probably a valley. It isn't necessarily a valley. Here's how you can tell. In a valley, these V shapes will always point uphill. So here's 150 feet of elevation. Here's 200 feet of elevation. So I can see that these V's are pointing to higher ground. And that's a key feature that we'll notice when we're in a stream valley. So in stream valleys, we'll see these V-shaped contour lines pointing upstream. So notice the water's flowing the opposite way of the V's. Now, let's not confuse this with other V-shaped features, which would be a ridge line. So if I look here, I see some V's here as well. I might think, well, maybe that's a river valley. Except if you look here, here's 400 feet, here's 350, 300, 250, 200. So these V's here are pointing downhill. And when I see that, I should think, that's not a valley, that's a ridge line. That's like a boundary between two valleys. And I know at first this might be a little bit difficult to see, but with practice, it becomes second nature. You just look at it, you start to see the land, kind of what we saw in this first picture here. You start to see it in your mind as three-dimensional. All right, let's keep going. Now, surface water is going to flow faster where the lines are closer together. Makes sense, right? So if I look at this map here, I notice here these lines are fairly close together. So water here I would expect to be running very quickly. And as we come down here, these lines are getting farther apart. So that means the water is going to slow down. It's not going to be flowing as quickly. So I can infer, like if I look here, the lines are quite far apart. So that tells me that the water here is moving quite slowly. But as I come up here, it's running very rapidly. It's almost a waterfall at this point. Now, for watersheds, though, this is an important concept. If you look carefully at these lines, you'll notice where the water crosses that line, it always crosses perpendicular. And that's because water wants to flow downhill, the most direct route downhill. And it's a good idea in trying to interpret contour maps to try to see where the watershed boundaries are, to just picture what water would do. So if I released water at this point here, it would flow straight downhill. In other words, it would flow perpendicular to all the contour lines. Water would flow this way, and then it's not going to go uphill, so it's now going to go this way. It's always going to flow in a way that brings it perpendicular to the contour lines. So if I released water, let's just say here, it would flow this way, perpendicular to the contour lines, and it would join the water here. If I released water here, it would flow perpendicular to the contour lines like that. So it's a good idea to try to picture the flow of water, okay, in order to understand. Now, keep this in mind too. It's not just surface water in streams that does this. It's also the water in the groundwater, the water that's below the soil surface is going to flow the same way. Gravity acts in the same direction for both of them. So even though we don't see it happening, groundwater here is flowing this way. Why is that important? Well, if I have buried, if I've buried some barrels with toxic chemicals in them and they leak, where would I expect to find that? Well, I wouldn't expect to find it over here, and I wouldn't expect to find it up here. I'd expect it to flow through the soil down this way, all right? Because it's just gonna follow gravity, which is always perpendicular to the contour lines. Now, what I can do with this then is I can delineate the boundaries of watersheds. So I look at a map like this. I see a stream here, and I see a stream here, and I say, okay, I want to define these streams as being part of a watershed. Where are the boundaries of this watershed? Well, so I do is I go up to the top of the stream. I say, okay, if I keep going up, I'm going to get to a point here where I get to a ridge line, a little saddle area. And on the other side of this, notice the water's now going to go down into this stream. So at this point here, and it's labeled here ridge, which kind of helps, water here would flow down into this stream, and water here would flow down into that stream. So this makes the boundary. And notice here's a concentric hilltop show up these little bullseye patterns. So these ridges often will have, and if you look here, this is 7,515. And if I look here, I go this way, I see this one is down to 6,800. So I'm going downhill. So this is not a stream valley. This is a ridge line. All right. Now, so ridge lines make the boundary between them. So I've got this boundary here marked out. All right. Now, if I go this way, these V's are pointing downhill. So that's a ridge line. So I think, well, where would water here flow? Well, water here would flow this way. So that's still in this watershed, right? But if I let go of water here, yeah, that would also flow into the same stream. So I'm going to say this is the outflow point. This is where all the water in this watershed is coming out. So the boundary would then be here, because water released here would not go into this stream, but water released here would. So this ridge line here, I'm sorry, right here, this ridge line is going to delineate the boundary between this watershed and the adjacent watershed, because water here would flow into this river, but water here would flow into this one over here. And I can do the same thing over here. If I release water at this point here, it's going to go downhill like this. If I release water over here, it's going to go perpendicular to this. It's going to go into this stream over here. So this ridge line here, which looks like V's, but these are pointing downhill, not uphill. So this is a ridge line. Now, what do I do when I get to here? Well, water here would flow that way. That's not part of my watershed then. But water here would flow into my stream. So this ridgeline here is going to make the boundary to this watershed. So there's my watershed. What that means is all the water that falls in this area here is going to drain into this stream, whether it's on the surface, in this blue water we have here, or in the groundwater. All of the water in this area that we can delineate here by following these ridge lines is going to is going to flow out at this point right here, which is, oh, I just noticed there's a red point here. There's my discharge point. Now, the boundary between two watersheds is called a divide. So I don't know if you've heard of the Great Divide, but in the United States, we have a Great Divide. It basically, all the water on the east side of the divide drains into the Mississippi River system and comes out near New Orleans. All the water on the west side of that divide will drain usually into the Colorado River or the Columbia River and come out in the Pacific Ocean. So you can say that we have these giant watersheds. The Mississippi River system is one huge watershed. Okay, I think that's pretty much all I need to. Oh no, one last thing here. There's a symbol we have to get used to. This symbol here, it implies that there's a marsh. So when you see these symbols, it means that you've got like a wetland or a swamp or a marsh. And so you might see these on the maps that we're working with. Okay, thanks for watching.